Another example on solving for the BSA and finding its recommendation. BSA again is the body surface area. We have a child who is 30 inches tall and weighs 25 pounds. So if we're going to stick with those units, we have a formula that we need to use, which is BSA is approximately equal to the square root of my inches times my pounds, all divided by 131. So, in this case, we have a patient that weighs 30 inches tall, that weighs 25 pounds. We're going to divide it by 31, and then square root it. So, 30 times 25 is 750. Divided by 31. Remember, we're going to have to square root our answer in the end. So this gives me 750 divided by 31 gives me a really big decimal. Or excuse me, a lot of decimal places, not so much a big number. So once I have that, I'm going to say square root this answer. And I'm going to round to the nearest hundreds, and my unit is meters squared, so this patient has 0.49 meters square of body surface. So now we're going to go to the next question where it says recommended dosage for this patient. Well, up here it says that we recommend 250 milligrams per meter squared. So I'm going to take my patient, and remember the patient always goes on top. And I'm going to multiply it by the recommendation, and we're solving for how much the patient could take, so that means the milligrams need to go on top, and of course we want the meter square to reduce, so that needs to go on bottom. And if I can go through here and mark the meter squares out, then I did it correctly. So now I have 0.49 times 250, which gives me 122.5 milligrams. This is what's recommended for this patient. And again, whenever we're trying to determine if it's safe or not, I would actually use the decimal before I rounded. I would actually take this, square root it, then multiply it by the 250, and then round. Because if we're not careful, the thousands, even a hundredths or a thousandths of a point can cause this one way or another. But for just mathematics' sake, we went ahead and rounded because I asked for it here. So now it says, is this order safe? So we look at what the order called for. The doctor said to administer 122.5 milligrams, and that's exactly what the recommendation said that they can take. So since the order is not bigger than this recommendation, then I'm going to say yes, it's safe. But I just want to take a second. I said a while ago that I would took this here and determined if it was safe or not. So if I was to say, all right, I got the square root of the 0.2395400083, square root that, and then multiply it by the 250, right? If I would have did that, let's just double check. Sometimes it comes out great. Sometimes that thousandths of a point will cause that hundredth to be significant. And we're going to multiply it by 250. So this here actually gives me 122.36 if I round milligrams. If this was the recommendation, and if we was to go exactly accurate, we'd actually say this was not safe, right? Because 122.36 milligrams is less than, right? So that means the order was bigger than the recommendations, then I would have said no. So we have to be careful. Be sure and read my directions on the homework assignments on what I'm asking for. And when you get into the nursing program or the health field programs, whichever area you go to, therapy, whatever it is, make sure and listen to what they say if they want you to wait to round at the very end. Because if you notice, 0.36 is a big difference between 0.5. and it could cause some issues. So if I was to use this one here, I would have said no, the order is not safe because the order is more than the recommendations. But if I would have rounded, I would have said yes. So there's a gray line there. So whenever you make your statement if it's safe or not, you need to state that based upon, oops, sorry guys, up on my findings, the recommended for this child, and I'm going to abbreviate, for this patient, 122.5 milligrams, and then I would say is safe. Or if I was to use that method there based upon the recommendations, you know, you got 122.36 milligrams. It's not safe. So, I mean, this is not exactly clear on the statements on how exactly you would write it. I kind of want you to find your own wording. But you would definitely want to explain. And your math will also support your findings as well. So as long as you show your math, then you're able to support your findings here on your statement. And then if it is safe, we want to convert it to milliliters. So we know that milliliters is volume and milligrams is weight. I also know that based upon our formula sheet that 1,000 milligrams equals 1 gram, right? And on that formula sheet that I got from the nursing department, it says that 1 ounce is equal to 30 milliliters. It also said 1 ounce is equal to 30 grams. So then that must mean that a milliliter is approximately equivalent to a gram. If this is true, of course you got to remember we're talking about volume versus weight. If this is true, then all I need to do is convert those milligrams to grams, and then I know what my answer would be. But just note that in real life, this is volume versus weight. They'll have a different structure and they will look different. They'll have a different format. So if we're going to do that and we're going to say yes, if my answer is going to be yes in this case here, then I'm going to take that 122.5 milligrams. I'm going to divide it by 1,000 milligrams. I'm going to multiply it by 1 gram. And what do I have? And I'm using a calculator to speed up time and to double check my answer. I would have 1.225 grams. I'm going to round to the nearest hundredths. And I'm going to say it's approximately equivalent to the milliliter. And that is using BSA on recommendations.